Welcome to homework.
All right, we have got a secondary amine, which is diethylamine, and we are reacting this with acetic anhydride, and we're asked what the product will be. Uh, Now, recall that acetic anhydride is very similar to something like acid chloride, and that if we have something mildly nucleophilic, that nucleophile will attach here. We'll get our tetrahedral intermediate with our nucleophile. And this negative charge will swing down and kick off the chlorine. But instead of kicking off chlorine, we're kicking off an acetate ion. But other than that, it's the exact same process. Now there will be some protonation and deprotonation steps as well, but that's the overall mechanism, in terms of the structure. So really, all we need to do is consider that this bond that was previously to the oxygen is going to be to the nitrogen. And that proton on the nitrogen will be removed, likely by this acetate ion. Right? So instead of a bond to the oxygen, we'll have a bond to this nitrogen. The nitrogen will still have its two substituents, ethyl, ethyl. It will no longer have the proton. And then we should expect to have an acetate ion, but it will likely have picked up that proton from the nitrogen. So we should end up with, acetic acid. The other option would be to draw a protonated form if they're specifying that it must be ionic, which would be weird. I don't know why they would want to see it like this, but chemistry programs are never great. Then we would have a proton here and a positive charge, and the counterion would just be the acetate ion. So it's either these, where this is the major organic product, or it's these, where this is the major organic product. Looks like you were on the right track. So maybe if you tried the ionic form, try the not so ionic form.